Hello everyone. Today we are going to look at the paper presentation on training language models to follow instructions based on human feedback. And names, as the name of the paper suggests, it's focused on the training the language models to be more human oriented and based on actual human feedback. So I'll give you quickly a brief of the paper. The paper found that simply making AI models bigger doesn't make them better at following instructions. In fact, massive models like GPT-3 often produce unhelpful or toxic responses because they are only trained to predict the next word on the internet. To solve this, the authors created Instruct GPT using the RLHF, which stand for Reinforcement Learning from Human Feedback, for which they hired people to provide demonstration and rank the AI answers. This coaching taught the model to align with the human intent, and these results were pretty good compared to the GPT, and it's 100 times smaller than the GPT-3 and very much preferred by the human users. The Instruct GPT is more truthful, follows rules better, and it's less toxic. By blending human feedback with original data, the team avoided performance losses. This works prove that human guidance is most cost-effective way to build the helpful AI. As we can also see, the Instruct GPT has only 1.3 billion parameters compared to 175 billion parameters of the GPT-3, which is 100 times productions. So it's cost effective and very much preferred by the human users. So what's RLHF? So RLHF stands for Reinforcement Learning from Human Feedback, and it is the core idea behind this entire paper. To understand why RLHF is needed, we first need to look at how traditional language models are trained. Most language models like GPT-3 are trained using very simple objective, predicting the next word in a sentence based on the massive internet data. So while this makes them very good at generating fluent and natural sounding text, it does not guarantee that the output is actually useful or aligned with what the user wants, sometimes toxic as well. For example, the model might generate something that is factually incorrect, irrelevant, or even harmful to some. So this is where RLHF comes in. The idea is to bring humans directly into the training loop, and instead of learning from the raw text, the model also learns from the human preferences. So humans look at the different responses generated by the model and decide which one is better. For example, which answer is more has helpful, more accurate, or safer. So this feedback is then converted into reward signal. Using the reinforcement learning, the model is trained to maximize this reward. So in this, instead of just predicting the next word, it learns to generate responses that humans actually prefer. So in simple terms, RLHF shifts the goal from predicting text to behaving correctly. And this is what makes more model more helpful, more honest, and more aligned with the human expectations. So coming to the main goals of this paper, the goal of this paper is to improve how well language models aligns with the user intent. Even though models like GPT-3 are very powerful, they often fail in the practical scenarios. They might misunderstand instructions, give irrelevant answers, or generate misleading information. So the authors focus on improving three key aspects: helpfulness, honesty, and harmlessness. Helpfulness means the model should actually solve the user task and follow instructions properly. Honesty means it should not make up facts or give false information. And harmless means it should avoid generating toxic, biased, or unsafe content. So, for example, it's my own personal experience. Sometimes when I chat with the chat GPT, it generally gives me false answers, like something, the concept I know, but it gives me answers which are factually incorrect. So I have to correct it. And sometimes it's also start arguing with me that the logic it gives is correct. So that is basically very much harmful in longer use. Well, another important goal of this paper is efficiency. Traditionally, the approach to improving models has been to make the model bigger, increasing the number of parameters. But this paper challenges the idea. It shows that instead of just scaling up, we can get better results by improving how the model is trained. In fact, one of their key claims is that smaller model trained with RLHF can outperform a much larger model that is not aligned with the user. Finally, they also ensure that these improvements do come at the cost, do not come at the cost of performance on standard NLP tasks. So goal is just not alignment, but alignment without losing the capability. Now, before this work, most language models were trained using a next word prediction objective. This approach works well for learning grammar, structure, language patterns, but it has a major limitation. It does not teach the model to understand the user intent. So, as a result, even very large model can produce outputs that are incorrect, irrelevant, and sometimes harmful as well. So, this problem is often referred to as misalignment. At the same time, the idea of using human feedback is not completely new. RLHF had already been used in other domains like robotics, gaming, and in also self-driving cars. So in those areas, instead of defining a fixed reward function, humans guide the system by providing feedback on its behavior. However, applying this idea to large language model was still relatively unexplored. Most NLP systems relied heavily on supervised learning or predefined data set. So there was a clear gap. So we had powerful models, but not effective way to align them with the human expectations. So this paper builds on previous work and applies RLHF specifically to the language models. The goal of this paper is to bridge this gap and create models that are not just fluent but also useful and safe in real world applications. So you can think of this paper as combining two ideas, large scale language modeling and human feedback to solve this misalignment problem. Now coming to this model overview, this is the entire structure of this paper. So let's break this diagram down by understanding each block. So we start with trained LM, this trained LM. So it stands for trained language model, which is the main model we want to improve. This model generates text responses based on the input prompts. Then we have this reward model shown on the right. So its job is to evaluate the quality of the generated text. It gives a score which represents how good or how preferred the response is according to the human feedback. Now below that we have this frozen language model. So this is basically a reference model that does not change during training. It just helps us compare how much the trained model is deviating from its original behavior. So that's where this scale loss block comes in. So it's check for the KL divergence. It measures the difference between the trained model and the frozen model. So this ensures that while improving, the model doesn't start generating strange or meaningless output. Now both the reward from the reward model, the first reward given from the reward model, and the KL penalty. This is now summed to make this final reward signal. So the final reward signal is passed to the RL update block using the PPO, which updates the model step by step. So overall, each block has a clear role, generation, evaluation, constraint, and optimization, all working together to improve the model safety. Now coming to the training pipeline, now let's understand how the data actually flows through the system step by step. So the first step here, we start with a prompt from the data set. A human labeler with high, this human labeler is writes a high quality response from that prompt. This data is used to train the model using the supervised learning, which is called a supervised fine tuning on or SFT. And now coming to the second step. So instead of writing answers, we generate multiple outputs from the model for the same prompt. Human then ranks this output based from the best to the worst. The ranking data is used to train the reward model so that it learns how to score different responses based on the human preferences. So, and in the third step, we move to the reinforcement learning. A new prompt is given to the model and it generates a response. So this response is passed to the reward model, which gives a score. So based on this score, the model is updated using PPO to improve its future responses. So this process keeps on repeating, generate, evaluate, update, forming a continuous learning loop. So the key idea is here to instead of directly telling the model that what is correct, we guide it using the human preferences at every step. So as we learned earlier, the SFT is the first step of this RLHF pipeline. So SFT stands for supervised fine tuning. So here what we do is human labelers are asked to write high quality responses from variety of prompts. These responses acts as a demonstration of how the model should behave. This then the model is trained on this data using standard supervised learning. So essentially it learns by imitating those human written examples. So this step is very important because it gives the model a strong starting point. Without this, the model would be too unstructured for later reinforcement learning step to work effectively. So at this stage, the model already becomes better at following instructions compared to the original GPT-3. So it learns how format answers properly, stay relevant to the prompt, and avoid obvious mistakes. So it's basically a major step that makes it stand out from the original GPT-3. So, however, there are still some limitations. The model only learns from the exact examples it sees. So it does not fully understand subtle preferences like tone, safety, or what makes one answers better than the other. Also, writing demonstrations for every possible scenario is not scalable because uh, you have to make some person come and give its responses, give his or her responses to every possible prompts. So that is like very tiring. So while supervised fine tuning improves the model significantly, it is still not enough to fully align with human expectations. That's why we move to the next step, where the model learns from the comparisons instead of just examples. Now coming to the second step of the RLHF pipeline. So what it does it instead of asking humans to write answers, we now ask them to compare multiple outputs generated by the model for a given prompt. Like so, the model produces several responses. The human labelers then rank these responses from best to the worst based on criteria like helpfulness, correctness, and safety. So the ranking data is used to train the reward model. The reward model takes a prompt and a response as an input and outputs a single score, which represents how good that response is according to the human preferences. So instead of hard coding rules like this is correct or this is wrong, the system learns preferences directly from the human judgments. So one important advantage of this approach is that it's capture relative quality. It does not just learn what is correct, but what is better compared to other options. So this makes the model more flexible and better aligned with the real world expectations. So the reward model essentially acts as a learned objective functions, which can later optimize using reinforcement learning. So this step transforms the human feedback into something that the model can directly learn from, a numerical reward. So now coming to the final step, reinforcement learning, it is used to improve the model further based on the reward model. The model generates a response for a given prompt, and the reward model evaluates by assigning a score. But this score is now you will be used as a feedback. The model is updated to produce better responses in the future using that feedback. So the specific algorithm used here is PPO or the proximal policy optimizations. So PPO is designed to make subtle updates so the model improves gradually without making the sudden drastic changes. So one important challenge here is that if we only optimize for the reward model, the system might exploit it. For example, it might generate unnatural repetitive outputs to get a high score, but that is not actually helpful. So to prevent this, a KL penalty is added. So this ensures that the updated model stays close to the original supervised model. So there is a balance which is improved based on the human preferences, but don't deviate too much from the natural language behavior. This combination of reward optimization and constraint is what make RLHF very effective. So overall, this step allows the model to continuously improve by learning from feedback rather than just static training data. Now let's look at the data set used in this work. So the data primarily comes from the prompts submitted by the user through the OpenAI API. These are the real world prompts, which makes the dataset very diverse and representative of the actual use cases. In addition to that, human labelers are also created their own prompts. So this helps ensure coverage of different types of tasks and avoid relying on the user data. So the data set is divided into three parts. The first part is used for supervised fine tuning, the second for training, and the third for reward model. The reinforcement learning. So in terms of size, the supervised dataset contains around 13,000 prompts, while the reward model dataset is larger, which is around 33,000 prompts. So these prompts cover a wide range of tasks such as question answering, summarization, brainstorming, chat, and content generation. So most of the data is in English, although the model can still generalize to other language to some extent. So overall, the data set is carefully designed to reflect how people actually interact with the language model, which is important for the real world performance. Now, the human feedback process. So human feedback at its core of this entire approach. So let's understand how it is collected. First, human labelers are trained to follow specific guidelines. So they are instructed to prioritize helpfulness, honesty, and safety while evaluating responses, not their personal agenda. So in supervised fine-tuning stage, they write complete answer from the prompts. And in the reward model stage, they are shown multiple responses and asked to rank them from best to worst. This ranking process is repeated across many examples, creating a large data set of human preferences. Around 40 trained annotators were involved in this process for this paper, and they are selected carefully through screening to ensure high quality judgments. Interestingly, this the agreement between the different annotators is quite high, around 70% or more. This indicates that the people agree on what makes a good response. However, it is also important to note that the model is being aligned to the preference of the specific group of labelers, not all humans, because the labelers are very small set of the whole populations. So while the system captures human feedback, it is still limited by who provides the feedback. Overall, this step converts subjective human judgments into structured data that can be used for training. So coming to the evaluation metrics. So we have built the model, but to evaluate this, how well this model is aligned, the author used both human evaluations and automatic benchmarks. The most important metric is the human preference. Labelers compare this output from different models and choose which one they prefer. This directly measures how useful the model is in the practice. They also use a Likert scale, which is from 1 to 7, to rate the overall quality of the responses. This gives a more detailed measure of the performance. And for truthfulness, they use a benchmark called truthful QA. This checks whether the model provides correct or non-misleading answers, especially for tricky questions. And for safety, they evaluate toxicity using the dataset like real toxicity prompts. This helps measure how often the model generates harmful or inappropriate content. They also test for bias using the standard benchmarks designed to detect unfair or discriminatory outputs. So instead of focusing only on accuracy, the evaluation covers multiple dimensions such as usefulness, truthfulness, safety, and fairness. So this makes the evaluation more aligned with the real world expectations of the AI systems. Now the results. So which are the most important part of the paper. The authors evaluate their model using human preferences, and the result shows a clear improvement over GPT-3. So in most cases, human evaluators preferred the outputs from Instruct GPT over the GPT-3 models. So one of the most surprising finding is that even a much smaller model with only 1.3 billion parameters was preferred over much larger 175 billion parameters GPT-3 model. So this is very important result because it's a challenge. It challenges a common assumptions in machine learning that the bigger models are always better. Here we see that the alignment can actually be more important than the scale of the model. The model also performs better at following instructions. It produces response that are more relevant, more structured, and more consistent with what the user asks. So another key improvement is the reductions in the hallucinations. The model is less likely to make up false information, especially in the tasks where the accuracy is important. It and it also generates more appropriate responses, meaning it avoids harmful or unsafe content more effectively. So overall, these results clearly show that RLHF significantly improves the quality, reliability, and usefulness of the language model. Now, the coming to the key findings. So this slide summarizes the key insights from the paper. The first and the most important takeaway is that alignment is more important than the scale. So instead of simply increasing the model size to like further billions parameters, improving how the model behaves leads to better outcomes. Second, RLHF significantly improves user satisfaction. Since the model is trained directly on the human preferences, it produces output that are people actually find useful and natural. Third, the model becomes more truthful and safer. It reduces hallucination and avoids generating harmful or toxic content. Another important finding is the generalization. Even though the model is trained on the specific prompts, it performs well on the new and unseen tasks. This shows that it has learned a more general concept of following instructions. Finally, these improvements come with minimal performance loss on the traditional NLP benchmarks. So this means we don't have to sacrifice capability to gain the alignment. So overall, RLHF provides a balanced improvement, better behavior without losing the performance. Now the limitations. So now, even though the results are very impressive, the has several limitations. First, the entire process depends heavily on the human labelers. Collecting high quality feedback is very expensive, time consuming, and not easily scalable. Second, the model can inherit bias from the labelers. Since it learns from the human preferences, any bias in those preferences can be reflected in the model's behavior. Another limitation is that a model is aligned to a specific group of people, not all users. Different users may have different expectations, so alignment is not universal. So this is also something called in alignment tax. So this means improving alignment can sometimes reduce performance on certain tasks, especially traditional benchmarks. And finally, the model is still not perfect. It can still make mistakes, fail to follow instruction, or generate incorrect information in some cases. So while concluding, so while RLCF is powerful approach, it is not a complete solution, and there is still room for improvement. Now, to conclude this presentation, this paper shows that a reinforcement learning from human feedback is a very effective way to improve language model. So instead of focusing only on making models larger, the author shows that aligning model with human preferences leads to much better result. And the Instruct GPT model very much outperforms GPT-3 in terms of usefulness, safety, and truthfulness, even though they are significantly smaller in size. So the highlight of this important shift in AI research from scaling model to aligning them. It also shows that human feedback is a very powerful tool for shaping model behavior by incorporating human preferences directly into the training. So we can build systems that are more reliable and user friendly. However, there are still many challenges such as bias, scalability, and ensuring alignment across diverse users. So overall, this paper presents RLHF as a promising direction for building more practical human-centered AI systems in the future. Now we'll see one example. If you can clearly see that on the screen. In this case, the prompt asks the model to create a shopping list from a recipe. So the expected output should be a list of ingredients extracted from the text. So first, we see the labeler demonstration, which is the ideal answer written by a human. It correctly identifies all the ingredients like zucchini, beef, onion, mushroom, cheese, and so on. Now, if we look at the GPT-3 output, we notice something very interesting. Even though its text is fluent, it completely ignores the instruction. So instead of generating a shopping list, it continues the recipe and gives cooking instructions. So these show a key problem. The model is generating text, but it is not actually following the user's intent. In contrast, the Instruct GPT output is much better. It produces a clear and structured list of the ingredients, which is exactly what the prompt is asking for. So this example highlights the main contribution of the paper, not just generating language, but understanding and following instruction very correctly. So this is exactly what RLHF enables, aligning the model's behavior with what the user actually wants. So these are some references from the paper. To conclude, I'll say that the paper shows us what we should ask, like how do we make the model behave better instead of asking how to make the models bigger. So this was my explanation for the paper, training language model to follow instruction using human feedback. I tried my best as per my understanding to explain this paper, and thank you so very much for patiently listening to me.